Hello class, welcome back again. We are doing chapter number 3, energy. So we have learned about energy and its unit in the earlier class. Today we'll be learning about different forms of energy like mechanical energy, sound energy, heat energy, light energy, nuclear energy, chemical energy, sound energy, etc. All right, but we'll begin with the mechanical energy first. So we have the topic here, different forms of energy. All right, so we are beginning this topic today. The first energy that we are going to learn today for today's session is mechanical energy. Now let us see what is mechanical energy, or what do you mean by mechanical energy. So as usual, I hope you are ready with your book and pencil, because I'll be asking you to underline as well as to write some of the meaning of some terms. So let's begin. Mechanical energy. What do you mean by mechanical energy? The energy possessed means it contained, the contained by a body due to its state of rest or of motion is called mechanical energy. So if you see a body which is having energy because it is in rest or because it is in motion, are you getting my point? Either rest, state of rest, or state of motion, then we say it as mechanical energy. Right? Are you getting my point? Now mechanical energy are of two forms. What are they? They are kinetic energy and potential energy. So please underline these two energies. So these are the two types of mechanical energy. They are kinetic energy and potential energy. So for today's lesson will be only dedicated to these two types of energy, because these two types of energy are very important for your higher classes as well. All right, so two forms of mechanical energy, the kinetic energy and potential energy. This is what we are going to learn now. Now kinetic energy, let's begin. A moving object can do work. See, a moving object can do work. Whenever you see an object which is moving, it can do some work. For example, let's see the example. A moving marble can be displaced at a stationary marble, that is there is a change in its position. Thus a moving object can do a certain amount of work that it could not do when it is in still. So when it is in at rest, still means rest. When it is at rest, it cannot do some work. But when this piece of marble was moving, it has the ability to do some work, that is to move from one place to another. So it is moving object can do works, which means it is changing its position. All right, similarly a speeding bullet can damage objects placed in its path. The running blades of a table fan can damage the object placed in its path, isn't it? If you place your fingers in a blades of a fan, what will happen? The blades of the fan will cut your fingers, isn't it? It will damage your fingers. Are you getting my point? So they possess energy. So whenever you see that an objects are moving, they possess energy. So similarly, running water of a stream can rotate a turbine to produce electricity. Similarly, the blow of hammer, moving object, can make a nail penetrate apart the hood, overcoming the force of resistance. So you see that the hammer, when you are hammering a nail, the hammer is in motion, it is moving. That's why it is able to do the work, that is to push the nail into the hood. काँटी ठोक्न कसरी सक्छौ? मार्तोल काँटीको माथि राख्यो भने काँटी गाडिन्छ? गाडिँदैन नि त, isn't it? So you have to heat it, means you have to set the hammer in the motion. So whenever there is a motion, the body possesses energy, and that energy possessed by the body is called kinetic energy. So in all these examples, we find that the motion of an object is involved in doing a work. Thus the ability to do work by a moving body to produce mechanical work is known as kinetic energy, or in simple words you can say the energies possessed by the body which are in motion is called kinetic energy. All right, so this is what definition that you get for kinetic energy. So here you can see a person is hammering the nail on the hood. You have a blades of a table fan which is in motion, rotating. These are some examples of kinetic energy. Similarly, you can see whenever you are hitting a ball The ball rolls on the ground, so ball is in motion, it possesses kinetic energy. A car which is running possesses kinetic energy. When you yourself are running, it possesses kinetic energy. When you are moving your hands, the hands possess kinetic energy. So what I basically trying to say is that whenever you see that an object is in motion, it possesses kinetic energy. Now, what is the formula to express kinetic energy or calculating kinetic energy? So here we have the formula for calculating kinetic energy, and the formula is kinetic energy is equals to half, okay, here 1 by 2 means half, multiplied by mass into velocity square. Okay, in short we can write as Ke equals to half mv square, where m stands for mass, v stands for velocity. So thus we can say that the kinetic energy depends on the mass of the body and the velocity with which it is moving. So there are two factors, okay, you can write here two factors, okay, on which kinetic energy depends. You write here, okay, here you have a rough space for rough work, you write here with the pencil. Okay, two factors on which kinetic energy depends are number one mass, okay, and number two it is velocity. So please note this down. All right, so these are the two factors on which kinetic energy depends. All right, what are they? Mass and velocity. All right, okay, so now let's go to the next page. Now when you turn your page, okay, on page number 45, you will come across this page where numericals which are based on kinetic energies are given. Example number 1 is here. Calculate the kinetic energy possessed by a body of mass 30 kg moving with a velocity of 10 meter per second. So you know that whenever you are doing some numericals, you have to follow the rules which I have told you, isn't it? So here the rule number 1 is to jot down the information given in the question. Okay, so here mass m is given 30 kilogram, velocity v is given 10 meter per second. So now apply this in the formula here. Okay, kinetic energy is equals to half mv square. Put the values and you are getting the values as 1500 joules. So this is how you can apply the formulas to find the kinetic energy. All right. Okay, now in example number 2, you see that it says calculate the kinetic energy of a body of mass 4 kilogram moving with a velocity of 0.2 meter per second. So two information are given, one is mass and the other one is velocity, and you know the formula to find kinetic energy is K equals to half mv square. So these are the two values given in the question. Put these values here in the formula and calculate, you will get the solution. This is how we apply the formula for kinetic energy to solve the numericals. Okay, so when we complete the chapter, we will do the numericals which are based on kinetic energy. All right, okay, so the first mechanical energy today we discuss is kinetic energy. Now we are going to the other mechanical energy, that is potential energy. Now see, as I said you in the earlier, that mechanical energy is the energy possessed by the body either when it is in rest or it is in motion. So just now we learned that whenever a body is in motion, it possesses kinetic energy. So जब body motion में छ त्यति बेला भएको energy लाई we call it as kinetic energy. So now when the body is in rest and the energy possessed by it is called potential energy. So you must have seen that some toys which when released after being wound up begin to move. You have seen some toys, so like in you have played also. So small cars जसको त चाबी हुन्छ, त्यो चाबीलाई बटारेपछि चाहिँ भुइँमा राख्दाखेरि आफै कुद्छ नि. So what you are doing, you are wounding up. त्यो चाबी लाउँदैछौ. चाबी लाउँदाखेरि चाहिँ you are wounding up the spring that it has, which stores the energy. Okay, and this energy stored by this deformation is called potential energy. So also old-fashioned clocks or watches are wound once a day or once a week. Why? This is because a wound up spring in the toy or in the clock possesses energy and enables the toy or a clock to work. This energy possessed by the spring is called potential. So I will give you the definition, proper definition of potential. Okay, now when we complete this video lecture today, okay, you will get the assignment for today where you will get question and answers based on the discussions that we did today. Okay, so Actually, you can define potential energy as the energy possessed by a body, okay, by virtue of its position or its configuration. A position भनेको चाहिँ के हो भन्दाखेरि चाहिँ, for example, when I lift something up, okay, something up. Suppose I take one watermelon, okay, watermelon, I take it up to a certain height, okay, and I then leave it. When I leave the watermelon, what will happen? It will fall down and strike on the ground and it will break. So why it is happening in that way? Because when I lifted it, it was raised to a certain position. So when it is at certain height, it has energy stored in it due to the height. Height ले गर्दा चाहिँ के हुन्छ? Energy हुन्छ उसकोमा. So that's why it falls and breaks. Similarly, when the water is falling from higher level to lower level, water, when it is at a higher level, it has energy stored in it, which is called as potential energy. So the energy possessed by a body due to its height, because of its height, is called potential energy. All right, are you getting my point? Now, when the energy is possessed by a body due to the change in its shape or size, त्यसलाई त भन्छ configuration change हुँदाखेरि. For example, here you can see there is a lady who is trying to shoot an arrow with the bow, isn't it? So bow ko string, when you stretch the string of the bow, you are deforming, you are changing the shape of the string. So the energy stored in the string due to this changed shape is called potential energy. Similarly, here we have a boy who is pulling the caterpillar. Okay, so when he pulls the rubber here, he's deforming the rubber ko shape ke huँदैछ, change हुँदैछ. So the energy stored in that changed rubber is also called potential energy. All right, so here you can see in this side of the page that there are types of potential shown here. Potential energy are of two types. One is gravitational potential energy, other one is elastic potential energy, which I've explained you here just now. The energy possessed by a body at a height above the ground is called gravitational potential energy. So the watermelon, when I lifted the watermelon to a certain height, the energy stored in it was gravitational potential energy. Similarly, in the river Tista, you have seen a dam, isn't it? So that dam is blocking the water in the river Tista. So the water is getting accumulated, pani thuprindecha, and the pani ko height ke hundecha, badhdecha, isn't it? Yes. So when the height of the water is rising up, the energy stored in that water is gravitational potential energy. Are you getting my point? Yes. That is why the water tank in your home is also placed on a certain height. तिम्रो कल भन्दाखेरि अलिकति अग्लो हाइटमा ट्याङ्की राखेको हुन्छ, पानीको ट्याङ्की. Why? So that water can easily flow from higher level to lower level, because when the water is at a higher level, it possesses gravitational potential energy. Understand? Similarly, the other type of potential energy is elastic potential energy. Now, what is elastic potential energy? Energy stored by a body when you are deforming it, when you are changing its shape or size. Are you getting my point? When you are tying your hair, the girls, when you tie your hair, you tie the hair with the rubber band. So rubber band like के गर्छ, तन्काएर बान्छौ नि त, हैन? So when you are stretching the rubber band, it has elastic potential energy. Similarly, here this boy in the figure is pulling the caterpillar. Okay, so what happens? He pulls the rubber there, gets stretched, so the energy stored in it is elastic potential energy. All right. Okay, then if you go to the next page, okay, I did not click that photo, okay, but if you see in the next page, you will see the formula, okay, for calculating gravitational potential energy. Are you getting my point? So in the next page, you will see that on the top there is a definition of potential energy. So please underline that. The energy possessed by a body by virtue of its position or state is called potential energy. So please underline that. Okay, and after that you have the formula for potential energy, that is gravitational potential energy. So gravitational potential energy is given by the formula mass into, okay, G into H, or you can write it as mgh. यहाँ m भनेको चाहिँ mass. What is G? G is acceleration due to gravity. Okay, and what is H? H is the height at which my watermelon was raised up. Okay, and when I raise that watermelon up, it is being pulled by the earth, isn't it? So the when I leave my hand, the watermelon falls down with the force and it moves with certain acceleration to acceleration, this G over here. Okay, and what is m? M is the mass of the watermelon. So again here your two examples are given there where the formula for potential energy mgh is used. So please go through that. Okay, so that's all for today. So before I finish up my video lecture, let us have a quick recall of the things that we did today. Okay, so after you complete this video, you please copy the notes which I give you after every video lectures. All right. Okay, so today we did about mechanical energy. Mechanical energy is the energy possessed by a body when the body is at rest or body is in motion. So that's why you have two types of mechanical energy. The energy possessed by the body when the body is in motion is called kinetic energy, but when the energy possessed by a body because of its rest position is called potential energy. Okay, the formula for potential energy is mgh, that is mass into acceleration due to gravity into height, whereas the formula for calculating kinetic energy is half mv square, where m is the mass of the body and v is the velocity. All right, then potential energy were of two types. One was gravitational potential energy and the other one was elastic potential energy. Okay, so these are the things that we have discussed today. Okay, so please now follow the class group and copy down the notes which I've given there and also learn them. All right, so that's all for today. Goodbye.